should not be breathing any paint, either it's paint dust, vapor or solvents from any kind of spraying. It is harmful to your health. This build is for acrylic water-based airbrush painting only, but if you want spray painting, you must just replace regular fan to a fan that is safer to use, for example furnace fan. Hola! My name is Danijela and welcome to my very first video. I wish to craft different things with 3D pen, and for this purpose I need to build an airbrush spray booth first because I want to paint indoors. In this video, I took the opportunity to learn some new skills as content creator and share with you what have I learned on the way so that you can build one yourself. So what we will cover? Enclosure, so that we minimize overspraying the air to keep everything contained. With filter frame and filter, which will collect paint particles. Lighting to lighten working area. Ventilation, so that all those potentially harmful particles and vapors go out. And the last, cable and hose management for finished look. If you are interested in a specific topic, you can find all timecodes in the description box below. Some things may not be available in your area, even I had to compromise. So I did some research and found a few options, but some of them didn't work as expected, for which I will explain why later in this video. For our spray booth we will need rigid foam board in a total of 5 sheets of 50 by 50 cm. Then a Noctua fan designed for heavy industrial applications that require high airflow. The more suction, the better. For next, you have two options. The first option is PWM USB cable, which can deliver up to 12 volts of power, otherwise it will not work. You don't need exactly this adapter, but you can use simple phone charger with USB plug that has 5 volts output. And the second option is step-up voltage regulator with micro USB input combined with micro USB to USB cable and regular phone charger powered by at least 2 amperes. Then we will also need 4 anti-vibration mounts for the fan from Noctua. To illuminate the scene, you can choose between this RGB LED strip or dimmable LED under cabinet / fit light, or dimmable LED strip set which have a cool white color with the possibility of cutting according to the cutting mark, and some leftover 45 degrees LED aluminum profile corner. Next is 30 by 50 cm replaceable filter, universal reducer for ventilation systems, a PVC exhaust hose with 10 cm diameter. This one is 3 meters long, which was too short, so I replaced it with 6 meters. And the last is one cable tie. Let's go assemble those pieces together. The booth is made of rigid foam board, which is inexpensive, relatively durable, light, easy to handle and flexible. However, it is sensitive to pressure points and scratches. Leave black sheet as it is, 50 by 50 cm, which will be the base. First, start with the two sides of the spray booth and draw 3 lines that will guide you while cutting. The first line is to limit the desired height. The second line is recommended to be at an angle because of the ventilation system and to save some space on the table. And the third line is also at an angle so that the hands can move more freely with the airbrush. With the next sheet, measure and mark for the back 20 by 50 cm and the top 20 by 50 cm. The last sheet will be used for the ventilation system. Measure and mark 21.5 by 50 centimeters. It's time to cut everything out with standard craft knife. At the first look, I didn't expect it to be so hard to cut, or the knife isn't sharp enough. Just kidding, it's brand new, but I am weak. Anyway, I had to cut a couple of times along the drawn lines to snap it neatly in half. The protective layer over the sheets is no longer needed, so peel it off. Now put it all together. For this you need a hot glue gun and about 10 glue sticks. Starting with the sides, place it next to the black square sheet and hold it upright. Then slowly glue it between them. For better strength and to improve the overall appearance of the spray boot, apply a thick layer of hot glue to all inner sides. It takes 5 minutes to cool it down, and in the meantime I pushed it together to make sure it sticks evenly and that there is no gaps in between. Repeat the same on the right side. Try to keep it as straight as possible while it cools, and it doesn't have to be perfect as the foam is flexible. Now let's attach the back piece. It is easier to glue the bottom first and then the sides. Here I am flipping the back piece inwards to make the whole piece look nicer. Reposition it a little more and let it cool down. I don't mind that this thick layer of hot glue looks a bit messy, as most of them will be hidden behind the filter frame later. For the opening of this fan piece, first mark the center point of the sheet that will help you to draw the circle for the hole. The diameter of the fan is 14 cm. It's better to cut a hole big enough not to obstruct the ventilation. Instead of a ruler, you could take a compass, stretch it to the desired length and just draw a circle. To draw the points for the mounting holes, mark the holes using the fan itself and the drill bit, or anything that fits into the hole and is pointed. Also highlight the points with a pencil for better visibility. Finally, use a craft knife to cut the big circle and a 5mm drill bit for the holes. The fan will be mounted using a Noctua anti-vibration mounts, which are designed for quick installation. They reduce vibrations and unnecessary noises. It's highly tear-proof, made of silicone, and as you can see, the mount has double-sided design, which means that you don't have to screw it on, but just push it through, as you will see shortly. Take one mount and push the shorter part into the hole, then pull on the other side until it snaps into place. It's important that narrower parts go through first, because the board is thin and will hold everything tight together. Do the same for the other 3 mounts. Finish this part by securing it at an angle of inclination. And lastly, glue the top piece together and let it cool. The enclosure is finished. It has gained structural strength, it looks nice and it's functional. For the filter, measure and cut out 30 by 50 cm from a 1 by 1 meter filter roll with a thickness of 2 cm. It is advertised as a spray boot filter and made of polyester fibers. I had some difficulty finding it, but it can be purchased and cut to the desired length. Use the pre-cut filter as a template for the filter frame. The filter will be positioned in the upper part of the boot and a few centimeters away from the fan opening. The bottom edge will be about 10 centimeters to save some filter material, and the frame itself will be at a slight angle to allow more room for painting. To do this, measure the height and decide on 42 centimeters so that the frame will be a little away from the back of the enclosure. With that in mind, pre-plan the frame using the leftovers from before. So, if we have 42 centimeters of total height, and the filter is 30 centimeters, now we are left with 12 centimeters, to which we add 3 centimeters, and end up with 15 centimeters of bottom border. The rest around the border will be enough if it's only 3 centimeters wide. Let's draw and cut these leftovers to size. It's just that you need to make the frame a little smaller than the enclosure because of the thickness of the foam. Not like me when I made a rookie mistake, as the frame didn't fit in the enclosure just because I left the frame to be 50 centimeters wide. So I had to cut off half a centimeter on one whole side. Place the pieces where they will be placed and secure them together with additional 1 by 2 cm small pieces of foam for better stability. To fix it, apply glue to the cross section around and around the edges and repeat for the other 3 corners. The frame is done, but the filter can still fall. Use more leftovers to make a holder that holds the filter well in place to prevent it from bending. It is also important to reinforce with more glue on both sides and allow it to cool before each pass. Now all that's left to do is to surround it with glue to secure the filter to the back of the spray boot. I recommend gluing the back underside first before going around the front, so that it doesn't slide inwards when gluing the rest. Then turn it sideways for a better approach and continue gluing as usual to finish off. Here is the unit all put together. It has become very strong and light. I can move it around and no part will fall off. As I will be creating and shooting videos at the same time, I need a lot of light on top of where I will do the painting. So I have tried 3 different LED lights and here's my honest opinion. The first one is this RGB LED strip for backlighting the screen. It has 9 color options and 5 brightness levels. I found that the intended white light illuminates more on the purple side and the intensity is just right, but it could be higher if something needed to be illuminated more. The second one is LED cabinet/fit light. It is exactly 50 cm long, has natural white color, and most importantly, it can be dimmed. And these are the specs. At the first look, the white color is perfect, but right after that, the light started to fool me around. When you dim it, it jumps too much. Either it's too bright or too dark, as it's not accurate enough and is clumsy to control. Furthermore, when it's facing downwards, it's even harder to control. Here's a comparison between those two. They are not bad, but they are not good enough either. I am dreaming of a light that can be cut to length, has a cool white color, with adjustable high luminous intensity and manual dimmer. Like this one in my dream. Oof! When I woke up, I went back to Amazon and bought this dimmable LED strip set. And that will be the third option. According to the ruler, one strip is 5 cm long, which means that you need 10 strips for a 50 cm wide boot. From the part where the connector is, shorten to the required length at the copper-colored cutting marks. The rest of the strips I will save for other projects and buy additional DC power connectors. Now take the LED aluminum profile corner, measure to 48 cm and cut it. The point is that it's a little smaller than the spray boot, as before with the filter frame. Use double-sided adhesive tape to stick LED strip to the profile and wrinkle it a little bit at the end, because the strip is a bit longer than the profile. A diffuser is included in addition to the profile, so cut it according to the length of the profile and snap it into place. It will help to soften shadows, reduce glare, and enhance light distribution in hard light. To finish, just mark where the connector will be on the other side, cut a small hole and secure it to the ceiling of the body with a hot glue gun. I am really happy with this light. It's as bright as daylight, easy to control, and with the help of the white enclosure, it diffuses light better and makes the space brighter. The exhaust fan I am using is Noctua NF-A14-2000, industrial fan for cooling computers or servers that require high airflow. With the size of 14 by 14 by 2.5 centimeters, it moves 182.5 cubic meters of air per hour, emits 31.5 decibels, requires 12 volts of power supply to operate, and made of glass fiber reinforced polyamide. Small but powerful. The fan has a cable with a 4-pin PWM connector that allows you to regulate the fan speed, but this is not necessary in my case as I need maximum airflow. More on that later. You can pick this up on Amazon at an affordable price. Of course, it's not the most powerful exhaust fan, but I highly recommend the stronger NF-A14-3000 version, which has much more airflow but is louder, and the price is essentially the same. I will leave a link to this page in the description box below. Here are other options like this bathroom fan with 200 airflow, or this one with around 250 airflow. this fan has about 300 airflow, or any so-called duct fan / inline extractor fan. I haven't even done any research on window fans. For me, all these fans looks too big, maybe even too heavy for my build, and this one is pricey, but they can all easily compete with Noctua 3000 in terms of airflow. There are two ways to connect a 12V fan to the power supply. The easiest way is with a 4-pin PWM USB cable, which can provide up to 12V of power. You can just plug it into the USB socket and it will work. They usually contain voltage boosters to make this possible. Avoid products with an output voltage of 5V, as they do not provide enough power to the fan and the fan will not run at all, or at lower speeds. If you have a regular socket, you will also need a power adapter, which has 5V output and a USB connector. This could be this adapter with voltage regulator or a regular phone charger. A 3-pin PWM USB cable with 12V output can also work, endorsed by Noctua, as 4th pin is for voltage regulation. Without it, will run at full speed, which is fine. I ordered a 4-pin PWM USB cable through American Amazon, as I could not get it in my area. A bit expensive because of the shipping costs, and the sum is the same as if I had bought this 3-pin PWM. First time around playing with these toys, I connected it incorrectly. Managed to fry the PWM cable and the USB connector. Therefore, I was unable to continue with my first idea. I think the voltage booster on the PWM cable saved me from frying the fan too. The other option is a DC to DC step-up voltage regulator and an ordinary phone charger. Each booster comes in an anti-static bag to prevent damage to the electric components. Before I remove the booster from the packaging, I have to discharge myself by touching any metal nearby. The input voltage range is from 2 to 24 volts and it's powered via micro USB input, so it's very easy to plug in. To connect the fan to the output and make it work, you need to know a few things about electricity and soldering, but nothing complicated, just the basics. All about that later. I have decided to go with this option because the voltage regulator is accessible and very useful for many mini projects I want to do. I paid €8 for 5 boosters and the package arrived very quickly. And now to the action. First, connect everything together with a reminder that your phone charger must be powered by at least 2 amperes. Or you can also plug the cable directly into a USB socket. Fix it to the table with some adhesive tape and the potentiometer must be rotated 15 turns clockwise according to the seller's instructions before switching on. Then plug in the charger and set the digital multimeter to measure volts to 2 decimal places. Place the needles of the multimeter pen on the corresponding outputs, black to minus and red to plus. By looking at the multimeter, you need to set the booster to 12 volts, which is what this fan requires. As you can see, I'm well above 12 volts and have to turn the potentiometer counterclockwise to reach the target. To prepare the wires for soldering, unplug the charger from the power supply first as a safety precaution. Then cut the PWM connector off and remove some of the plastic tube around the wires. As you can see, here are 4 different wires and each has a different function. Yellow is plus, black is minus, green is speed control, and blue is power control. More about that you can find on manufacturer website where they provide details about pin configuration. You can leave the green and blue wires aside as the fan needs to run at full speed, so just focus on black and yellow for now. Next, strip both conductors for a length of about half a centimeter and with preheated soldering iron tin them separately. Then heat the output pads until the solder wire melts and solder together with the fan wires. In case when you plug the fan and it doesn't start immediately like this, it means that the phone charger is powered by less than 2 amperes. So make sure that the charger provides at least 2 amperes. Finally, stick the insulation tape around the exposed solder joint and the whole module. Before attaching the fan to the enclosure, mark and cut the hole where the wire will go through to the other side. In the next step, it's important how the fan is oriented, to pull the air out and not push it in. If you are not sure, plug in the fan and see where it blows. The cable goes through first and then, just like before with this piece of foam, push the mount through the fan mounting hole and pull it until it snaps into place. Repeat the same for 3 others. To let you know that this fan is not an explosion proof. I heard from many people when using aerosol spray paint, if the fan is sparking and there are enough flammable vapors around, it can ignite. This applies to all fans that are wired directly. The possibility is small, but it's better to find an explosion/spark-proof fan or blower, as the electric motor is located outside of the airflow. A furnace fan is one of those that are safe to use. They are powerful and quiet, but they are big, difficult to find and expensive. That's why I installed this computer fan, as they are more affordable and accessible. I'm going to spray paint outside anyway, because it stinks, even when it's drying. And this fan will be fine for my intended use as long as I only paint indoors with acrylic colors. To keep the cables from getting tangled and in the way, I recommend using Velcro tape. It's versatile, practical and can be cut to the desired length, which is perfect for this build. Cut the strips 4 or 5 cm long, as many as you need to arrange the cables. To attach it to the foam, just apply a little hot glue to the end of the strip, doesn't matter which side. I ended up using 5 strips of tape and placed them along the edges on the back of the enclosure. I think it looks better that way, as well the dimmer and the booster are well supported. To organize even more, tie the cable with a string in case if you ever want to untie and extend the cable, including 2 additional strips to hold the 2 heavy adapter heads next to the fan. Among the last things to be added is the universal reducer, commonly used for ventilation systems and can be easily attached above the fan opening with the hot glue gun. Followed by a PVC exhaust hose with a diameter of 10 cm. Due to the steel spiral coated with robust PVC plastic makes it very flexible, and the hose I have is 3 meters long, which is too short for my use, so I strongly recommend longer hose. To fix it, just simply put on the reducer, secure tightly with a large cable tie and cut off the excess. The only thing left is to manage this weekly hose. The solution for this is a support box attached to the enclosure. It doesn't need to be precise, just able to provide support with enough room around it to grab the hose. I decided to go for about 12 by 14 cm with 10 cm height. Once you have all the pieces, glue them together on the enclosure and this build is complete. So this is how I built my own Airbrush spray boot to suit my needs. Of course, there are many ways you can do it, and hopefully after watching this video, it will give you some ideas on how you want to build your own. In the end, I'm very happy with the finished results and surprised by how solid it feels. I also like the size, which could fit small or medium-sized creations. The total cost of this build was around 130 euros. Actually, I spent more than that because not everything went as planned. Compared to the in-store solution, my spray boot is larger, has a more durable enclosure, dimmable light, a longer hose, and the fan is quieter with a slightly lower airflow. In the future, I can modify it with a more powerful fan, a different filter or lights if I wish. I hope you enjoyed it and found it helpful. If you found any value in this video, hit that like button and comment down below if you have any questions, suggestions, or if you are going to build it. Let people know how it goes, because together we can learn a lot more from it. Thank you so much for watching and see you in the next video. I'm already excited!